So basically 8.4, they're giving us greater than, less than kind of things, and they want us to figure out which shading is right. I think this might be pretty straight ahead for y'all. So this says X. You tell me, what does that symbol mean? Less, huh? Yeah, remember the symbol has a small side, so the lesser thing is here, and the bigger, this is less, and the bigger thing is there. It's got a wide mouth side where the bigger thing is, and narrow side where the smaller thing is. So you could turn it around, and it would go the other way. Now the smaller thing would be here, and the bigger thing would be there, right? Depending on which way that symbol goes. He's got a wide side where the bigger thing goes, and the narrow side where the smaller thing goes. Okay, so with that in mind, this says, what side is X on? The wide side or the narrow side? Narrow, so X is smaller. So it's saying X is smaller than -5. Well, then when you go to a number line, you got like 0 in the middle, and -1, -2, -3, -4, -5. There's -5 right there, right? Which side of -5 is X going to be on if he's smaller? He's smaller, less. Yeah, smaller things are always to the left, aren't they? That's where the smaller numbers are, the more negative number. So X would be over here, wouldn't he? Y'all with me? Which means our shading, we always shade where X is. Our shading is to the left of -5. Is that good? Is that making sense? So which answer is right? A, B, C, or there's also the bracket parenthesis. Have we talked about that before? No. Okay. Wait, let's talk about that. So if the way the parentheses work, if you put like parentheses and like 2, let's say parentheses 2 to infinity. That sideways 8 means infinity. If you've seen that before. Means forever, infinity. So that would mean all the numbers from 2 to infinity, but not including the 2. Things just a little bigger than 2, like 2.01, are fine, but not 2 itself. Not right on the 2. Parenthesis just means you're around the 2. Whereas if you put a bracket 2 to infinity, then that would mean including the 2 straight on. So a bracket has a straight edge to it. So you're straight on the 2 all the way to infinity. Whereas the parenthesis means it's rounded. I always think of it as you're around the 2, you're close to the 2, but you're not right on the 2. You got to be like a little bigger than the 2, like 2.01 or 2.0001. Not quite 2 right on the money. Does that make sense? So the parenthesis does not include the edge. You're just around it. Whereas the bracket does. You're straight on the edge. And infinity always gets a parenthesis. Because you're never right on infinity, are you? You might go to the doctor's office and say, I waited forever. But you didn't really get to forever. You just started getting closer to it. So, right? So, make sense on that? So brackets include the edges. You're straight on it. Parentheses is close to it. So the shading here, the X is the shading. Is it include the -5 right on? No, it's only things less than. Not less than or equal. That would make the bracket be in there, wouldn't it? See, it's just less than -5. Like -5.01. -5.3, -6, -7, -8. Things lower than -5, but not right on -5. Tracking with me? So we can have a parenthesis there or a bracket there? Parenthesis. Right? What's our answer? A, B, C, or D? C. C it is. Everybody see that? Because it's parenthesis -5, and the shading is lesser numbers. Because X is less. X is less. All right, we good there? You want to try number 2? Don't say it out loud. Give everybody a chance to do number 2. Here's the little statement. Can you see that? I can make that bigger.
Do we need to do the second part to number 1? Yeah.
Oh, yeah, we should. I better do that. Thank you. Let's go back up and finish number 1. Okay, yeah. So they want the answer in interval notation. So what's interval notation? It means left edge, comma, right edge with parentheses or brackets as the case may be. So left edge, right edge of what? Of the chunk of shading. of the shaded chunk. So here's the shaded chunk of the true answer down here. Here's the shaded chunk. So what's the left edge of that shaded chunk? Well, the left edge is an arrow, which means it goes left forever. Well, the right forever is infinity. What's the left forever? Negative infinity. Negative infinity. What's the right edge of that chunk of shading? The negative 5. So it'd be negative infinity, comma, negative 5, parentheses on both, because we're not including either endpoint. You never have a bracket at an infinity, and the negative 5 has a parenthesis. So they both have parentheses, don't they? Infinities always get parentheses. So does the negative 5 on this. Make sense? Left edge, right edge. The order matters. You can't swap it. It's got to go from lower to higher, like how you read, left to right. It's got to be that way. Want to try number 2? Try number 2. Can you see the statement there? I'll make it a little bigger. It says that right there. One mistake I've noticed over the years of teaching is students try to read these statements always left to right. Now, it might be confusing because I just said this has got to be left to right, but that's interval. Interval notation must be left to right. But when you read an X statement, you don't always read left to right. You should start with the X, wherever he is. Start here. And think about what side of the symbol is he on. Is he getting the wide side or the narrow side? Is the X getting the wide side or the narrow side of that symbol?
The wide side.
He's on the wide side. He's on the open mouth side, isn't he? Which means the statement, well, what is being said about X if he's been placed on the wide side? He's bigger, right? When the wide opens towards him, it's saying he's the bigger one. And the narrow is on the negative 11 means he's the smaller one. So the X is bigger. This means X greater. Does that make sense? So I've had many students over the years, they go, no, Mr. Harrell, when it's this way, it's always left. They're thinking wrong. They're thinking you always read that thing left to right. That's not true. You just read what it says. Let it speak. It's got a wide side and a narrow side. The X is on the wide side. So the X is greater than or equal to negative 11. If it bugs you having the X on the right, you know what you could do? This has helped some students. Just turn the whole thing around. Symbol and all. That's the same truth. And if that's more comfortable for you, you could totally do that. Do you realize that says the same thing? X is still on the wide side, huh? X is still on the wide side. They both say X is greater, don't they? And people seem to prefer having the X on the left. So if it bugs you the other way, just flip the entire thing around, including the symbol in the middle. It's the same truth. So X is greater than or equal to negative 11. So are we going to greater? So if you're going to go to negative 11 and you're going to shade the greater stuff. What's greater, right or left? Right. Greater numbers are to the right. So you got to be negative 11. So here's negative 11 shaded to the right, but here C and D both have negative 11 shaded to the right. C has a parenthesis. D has a bracket. Which one's right? D with the bracket. This one, huh? D. So everybody see that because of the bracket? Why do we want the bracket? Because we have equals here. We want to include the negative. You could be greater than or equal to negative. You could be right on negative 11, right? That's the bottom of an equal sign, right? The two lines in equals, that's the bottom line. It's the bottom of an equals. So you can be greater or equal to negative 11. So shade to the right, and bracket straight on the negative 11.
That don't have interval notation?
Yeah, they do. It's just off the screen. So go ahead and give the interval notation now. Yeah, they do want the interval notation. They want the left edge, comma, right edge. So go ahead and give the interval notation there. Remember, you take the piece of shading, the shading chunk, and you go left edge, comma, right edge. Well, yeah?
So this is just a simpleton question. That X right there with the little line, what is that? How do I read that? What does that mean?
Oh, yeah, no, that's a good question, Erica. That's set builder notation. You won't have to do anything with it, but it's officially, it's called set builder notation. That little curly bracket is set notation. When they do curly brackets, they mean a collection. Like we're a set of people. This is a collection of X values. They're saying the set of all x values, that little symbol, I'm not going to quiz you on this, but it means the set of all x values, and then that straight line right there is actually math shorthand. You want to learn some math shorthand? Maybe not. It means such that. Isn't it funny? Math, if you go into higher math, after calculus, we prove things all the time, and we say such that so often. It's kind of a weird thing to say all of it, but you do in math. You say, this is true, such that, this is true, such that. They do it so often they developed a shortcut. They go, if I draw a straight line, that means the two words such that. So there you go.
You can ideally just ignore that.
You can ignore it. That's true. But since you asked, I thought I'd fill you in. But you can completely ignore it. You're totally right. It just means all the x values that do that. That's all that's important as a rule. All right, so you get the interval notation? Left edge, comma, right edge. So what's the left edge? Negative 11. And that's a bracket, right? Because, bracket there. And what's the right edge? Infinity. So negative 11 to regular infinity, huh? Always a parenthesis on infinity. We good? Left edge, right edge. It's always left of the piece of shading. Left edge, right edge. The order matters. For interval notation, it matters. Smaller to bigger. Good? Okay, try that one. So yeah, like Erica said, you don't have to pay attention to that stuff. Just all that matters is that rule they're giving us in the middle. There's the rule. I'll just grab that out. That's all that matters. So try that. So let's see if you can figure out which one of those. All right, let's read it. So, what's it saying? Basically, it's saying x is between negative 4 and 3. I'll show you the details of how it is saying that. But let me just tell you the big picture. X is in the middle. X is between negative 4 and 3. So the shading is between negative 4 and regular 3. So, and notice there's no equals at the negative 4. So is that going to, and there is an equals next to the 3. So when you equal, you include it, right? Which means there's going to be a bar at the 3. Well, I mean, there is a bar there. And that means there's going to be a bracket. Yeah, that's one of the ways I help students remember. BB, bar goes with bracket. This is no bar, no bracket. So it's going to be a parenthesis. Huh. Did that make sense? Let's go over that one more time. So first off, the answer is either going to be A or C. Right? They're the two that have shading between negative 4 and 3, which is what that statement is saying. And then you got to get the bar bracket thing right. So remember, a bracket has a straight edge, so that's for equals, isn't it? When you include the edge, you're equal to the edge. So BB is the easy way to remember that. Bar goes with bracket. B goes with B. Bar goes with bracket. So they have an equals bar, you're going to have a bracket there. And then with the negative 4, there's no equals bar, then there's no bracket. It's going to be a parenthesis. So B goes with B. So, all right. So we're going to have a parenthesis at negative 4 and a bracket at 3. Which one of those has that? C is our answer, huh? Does that make sense? And then what's the interval notation?
Parenthesis negative 4.
Yeah, just exactly what we're looking at. Parenthesis negative 4, comma 3 bracket, right? Parenthesis negative 4, 3 bracket. Bless you. Left edge, comma right edge. Make sense? On that? Is that good? Questions on that one? I can show you, if you care about the details, that is what it's saying. See, it says the x is greater than negative 4. It's bigger than negative 4. It's to the right of negative 4. It's bigger than. Bigger things are to the right. And it's lower than 3. See that? It's on the narrow side compared to 3. So it's smaller than 3. It's left of 3. So it's, it's between negative 4 and 3. If it bugs you, you can just turn the whole thing around. That's the same statement. That way you got the smaller one on the left. I think that's easier to read. See what I did? I just grabbed the entire statement, flipped the entire thing around, symbols and all. Right? That's the same truth, isn't it? And that might be easier to read. Smaller one on the left, bigger one on the right. They're trying to trick you by putting it backwards. We good on all that? All right. So they're wanting me to look at that graph, and they're saying, what's the domain of the graph? Now, domain, I don't know if you remember from last time, is possible x values. It's possible x values. So on a graph, it's easier to see because here's the x-axis right there. So when we say possible x values, we mean how far left and right does this graph go? Because those are all x values. Meaning, if I'm walking around on this graph, well, probably a better way to be would be if I'm walking around on the x-axis. If I'm walking back and forth on the x-axis and looking up, where would I see graph? Well, pretty much everywhere. Right? Because this arrow says up and left, so it just keeps going up and left. Right? So that graph goes up and left forever, and up and right forever. So that graph's going left and right forever. So as I'm walking around on the x-axis, where will I see graph? Forever left and forever right, because of those arrows. Right? That graph goes forever left and right. So what's forever left in math? Negative infinity, forever right's infinity. So the domain, they want interval notation, which means left edge, comma right edge. Parentheses always on infinities, huh? Because you're never right on infinity. Is that good for domain? Domain is just left edge, right edge of the graph. How far the graph goes left and right. And this one goes forever left and forever right. Now, second question, range. Guess what? If domain is how far left and right the graph goes, what do you think range is going to be?
Up and down.
Up and down. That's exactly what it is. So now, forget about all that x stuff. Range is this. It's the vertical coverage. So domain is the width coverage. Range is the up-down coverage. Again, the order matters. You got to start with the bottom first. Bottom. And then the top. The order, just like for domain, it's left edge, right edge. For range, it's bottom, comma, top. So bottom, comma, top. So what's the bottom? How low? If I'm a little person here, walking up and down on the y-axis, if I'm a little person walking up and down on the y-axis, how high up and how far down does graph go?
11.
That graph goes up forever, right? Doesn't this arrow mean up forever? Graph's going to go. I don't just mean where it hits here. I mean how high. That graph goes up forever, right here. It says up forever, right? So up forever. How low does the graph go? 0, right? It doesn't go below this, does it? There's no arrows down there, are there? Right? Isn't this as low as the graph ever goes? Isn't that the lowest point on the graph? And then it goes back up after that? Right? So the bottom of that graph is 0. So the bottom is 0. The top is infinity. Bracket 0, parenthesis infinity. Do you see that? Why? Because it hits the 0 height. Right there, right? It's at a 0 height, right on the money, isn't it? We want to include that 0. Straight edge at that 0, straight on 0. It hits it. So so we're doing bottom, comma top. The bottom, the lowest that graph ever goes is a height of 0, and the highest that graph ever goes is infinity. It goes up forever.
Is it always going to be a bracket for the range for the last one, for the first one? See how it was 0?
Yeah, no, they could be a little more tricky.
Okay.
Yeah. I don't know why they're giving you the 2 options. What's that first one? Oh, they want, do they want both? Find the range, select the correct choice below. Type in, the range is, boom, type in, use a comma, separate, oh yeah, no. No, we want this for sure. You want interval notation. Up there, same thing here, this one, they want interval notation. Yeah, so just do the interval notation one for our answer. We good on that? So domain, left edge, right edge, range, bottom, top of the graph. Let's circle. So start with the domain. So the domain is the width. The domain is left edge, right edge. So what's the furthest point left on the x-axis? You're using the x-axis like a yardstick. So what's the left edge of that graph? Right about there, which is at 1, isn't it? On the x-axis. What's the right edge? And it hits that 1 straight on, doesn't it? What's the right edge of that graph?
7.
Looks like 7 right there, doesn't it? 1, 7. Brackets on both, huh? It hits 1 and 7 straight on. That makes sense there? Left edge, right edge. Can you do the, what's it called, range? Bottom, top? So what's the bottom of that graph?
-2.
And right here, -2. What's the top? Right here, 4. So, and always do the interval notation answer. -2 to 4, bottom, top. Brackets on both, because we hit both points straight on. Want to include the edges, don't we? No infinities on that one. That circle doesn't go up forever or down forever. It stops. Good? Easy enough. Questions? So try that one. Find domain and range. So domain first off. Left edge, right edge. Left edge, right edge. How far left, how far right does that graph go? So how far left does that graph go? Yeah, well, it looks like this branch says I go down and left forever. This branch says I go down and right forever, right? That's what those arrows mean. Keep on heading that way forever. So how far left does the graph go? Forever left. Yeah, it's negative infinity and to positive infinity, huh? That good? That's how far left and right it goes? We good with that? And now, how about the range? How about the up and down? How low, how high? So remember, range is always bottom,
-1.
top.
No, -1, 0.
So what's the bottom of that graph? What's the lowest point on that graph? It goes down forever, doesn't it? There's no bottom, right? This arrow, right? See the blue graph? The blue graph says I go down, 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 down forever. In fact, both sides do, huh? So there's no bottom. It's bottomless, like an old bottomless pit. So negative infinity is the bottom of that graph. It has no bottom. And what's the top? -1 with a bracket. Right? Because right here's the highest point of that graph, and that's at -1. I don't know if you can see, it's kind of small. It's just 1 below the axis. So the top of that graph is -1, bracket, right on -1, huh? Is that making sense? Left, right, bottom, top? Questions on that? We good? Left, right, bottom, top? All right, so try that one. Left, right, bottom, top. For that little piece of graph. So domain, always choose the interval one.
You put bracket 3, and then you have infinity.
So left edge, right edge. What's the left edge? 1 right here. And the right edge is infinity because it goes right forever, doesn't it? Bracket 1 to infinity. We good? And what's the range? What's the up, down? So range would be bottom, top, right? Range is bottom, comma, top. So what's the bottom of the graph? What's the lowest point on that graph? Right here, 3. Bracket, hits it right on. What's the highest point on that graph? It goes up, 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 and away forever, huh? Infinity with a parenthesis, always a parenthesis on infinities. All right, it's getting easy, getting more comfortable. Left, right, bottom, top. Domain and range. Okay, so we have a graph there. And this is called a piecewise graph. Look at the answers. They're pieces of graphs, aren't they? So the whole trick on these is watching out for which graph is graphed in which section. So actually, before we dive in, let me give you a little reminder. How would I graph 3x plus 7? Let's just start with 3x plus 7. Do you remember how to graph straight line? Where do you start? Where do you get your first dot? Remember, you just need 2 dots? Yeah, you start with this one. 1, 2, 3, 4, 5, 6, 7. Boom. Up at 7, that's your first dot. Remember that number off to the right? If it's positive, it's up the middle, negative down the middle. It's always on the middle line, first dot. Okay, and then that's the first dot. Just need one more. Connect the 2 dots, get your line. How do you get second dot? Yeah, the rise over run, huh? This is 3 over 1. Rise over run. So you go up 1, 2, 3 over 1. Whoops, I'm not doing that right. 1, 2, 3 over 1. Then you just connect the dots, and there'd be your line. Okay, you remember all that, right? So they're going to give us that same thing now, but they're going to say, okay, you know that line right there? We only want it for x values greater than or equal to 0 or something. They'll give a condition. In other words, they just want a piece of it. They don't want the whole thing. That's why it's called piecewise graphing. They're going to say, just that graph goes forever, up and right and down and left, right? We just want the piece of it where the x-axis is the x-axis is greater than or equal to 0. Meaning if you're walking around on the x-axis, here's 0, here's 1, here's 2, here's -1, here's -2, etc. We just want the part of the graph that begins at x0 and goes for values greater than that. Greater than or equal to 0. Meaning what? What do they mean? Meaning we just want this part of the graph. That's the part of the graph that is from the middle over, which is what this is saying. From 0 and greater, middle over. Do you see that? You see how it's taking a graph and just breaking. So what about the other piece? Erase it. They don't want that other piece. They're saying we just want this graph only in that zone. How about that? They want it in a zone, a particular x zone. They'll let the x-axis tell us where. Then they might say, hey, and then, well, what about over here? Over here, I'll give you a different equation. Like, and they'll come over here and they'll say, oh, actually, I got it backwards, huh? They said less than or equal to 0. I'm trying to do that one. Let me go back. So they actually said they wanted this piece of it. They don't want that piece because I got this backwards. They actually said they want x less than or equal to 0. So they want the places 0. They want this zone, which is the left side of the graph. Does that make sense? See what this says? X less than or equal to 0. X values left of 0. We're doing good. Is that making sense? So they just want the left piece of that graph. And then they'll say, okay, what about over here? What about on the right side? We'll give you some other graph for that. Let's give you this equation. And that'll be for x values greater than 0 to the right. We'll say, okay, we'll give you, what was it, 1/4 x plus 1. And use that one when you're at values to the right of 0, greater than 0. How do you graph that? How do you graph 1/4 x plus 1? Where do you start?
1.
Start at 1, up 1, that'd be right here, up 1. And then how do you get your second dot? Yeah, rise over run, go up 1 over 1, 2, 3, 4, right there. Connect the dots. But don't go left. Let me erase that. Don't do anything left. We only want that thing greater than 0. Do y'all see that? So they're having two graphs, but just having pieces of each one. And then they kind of connect them up in the middle. Well, they don't touch, but I mean, together they both go to the middle line. Right? Is that making sense there? That would be the graph they're talking about. Everybody seeing that? So the graph 3x plus 7, left of 0. It's probably pretty sloppy. How about I try that again? This looks terrible when I was... Let's try this again. 3x plus 7. Let's do this one more time and try to be real clear. But only for values of x less than or equal to 0. So I'm going to graph, make a big graph here. And you know what actually I think would be easiest? Let me do this for you. Let me, what I just laid out was true. But here's the easiest way to go about it. Basically, when they give you a question like this, I'm basically answering this question right now. When they give you that kind of question, in fact, let me just rewrite that. That'd be the best way. What number is this? Number 8? Okay. And let me rewrite that one for you. Sorry, I keep changing my mind 27 times. Let me rewrite that all out for you, then we'll see it from there. 3x plus 7 less than or equal to 0. So 3x plus 7, x less than or equal to 0. And what was the other one? 1/4 x plus 1 greater than 0. I'm going to change the color. X greater than 0. Okay, so let's do it one more time. We basically have done it, but I want to do it clean with you one more time from the top. So what are they saying? So the first thing you want to do is figure out what they're saying. They're saying, we'd like you to do this equation for x values less than or equal to 0. Remember, this is the x-axis down here. Here's 0, here's 1, here's 2, here's 3, etc. Here's negative 1, here's negative 2, negative 3. So where do they want me to graph 3x plus 7? That first equation, 3x plus 7? Do they want me to graph it on the left side or the right side of the middle?
My left side.
The left, because it says x less than or equal to 0. They could have reversed that. So what that means is over here I'm going to graph 3x plus 7 on this side. And then on the right side I'm going to graph the other one, 1/4 x plus 1, because that's for values greater than 0 to the right. Does that make sense? They're basically giving you different regions, zones, territories to do two different graphs. Connect them up in the middle. So now we know how to graph, right? But I'm going to give you another suggestion that I think will be easier in this situation. And that is just plug in a couple of points. You know, like making XY points. Because I'm afraid if you do the whole equation thing, you might get messed up. So let's just plug in a couple of points. Let's do it that way. I'm going to plug in a couple of points on the left side. How about negative 1? And then how about 0, since that's right in the middle? Is it making sense how I'm picking? Why did I pick those points? I'm picking points. Remember, this graph exists left. So I'm picking, you could have picked any 2 points over here in the left, but actually you should pick 0, because that's right in the middle, and you need to see what they do at the middle, where they connect up. So I'm going to pick negative 1 and 0, and I'm just going to plug in those x values to what? To that equation. 3 times negative 1 plus 7, what's that?
Minus 3.
Positive 4. Minus 3 plus 7. 7 minus 3. 4. We good what I just did there? So I just plugged negative 1 into this function. And then I'm going to plug in 0. 3 times 0 plus 7. That's just going to be 7. Why am I doing this? That'll give me 2 dots for this equation. Back 1, up 4. Back 1, up 4 right here. Back 1, up 4. And over 0, up 7. Right here. Everybody see how I got those 2 dots? Back 1, up 4. Back 1, up 4. Over 0, up 7. Remember, first number's over, second number's up or down. We good? I got a couple dots. and then just connect the dots. There's the left side graph. That's the same thing we got a minute ago, right? See it? Same graph. I'm just kind of doing it more organized, keeping the left side on the left. Is that good? On that? Yeah.
So on the homework part, I saw that there's like open circles and closed circles.
Yeah, we'll
Are
get
we
there.
getting that? Okay.
Yeah. And now the right side, going to do this equation, going to do the same thing, make an XY table for the right side, but only always plug in the middle, so the middle's 0, huh? And then something in the right side, because you're supposed to use the red graph for x values greater than 0. Greater than 0. So like 1 or 2 or 3 or whatever. So let me pause for a minute. Is this making sense? Are you seeing how I'm choosing what to put in this table? They told me the black graph is x values less than 0, negative x values. And the red graph is for x values greater than 0, positive values. So I made a table for each one, and I just plugged in the kind of x values they told me to plug in. They said for the black graph, only put in things less than or equal to 0. So I put in 0 and negative 1. That's numbers less. And then I just got the y values and put the dots and connect the dots. Right? And then on the right side, I'm going to plug in x values greater than 0. Now, if they said only put in x values, what'd they say here? Bigger than, greater than 0. Can I actually put in 0 itself? No, they didn't say less, greater than or equal. They just said greater. So you can't really put in 0. So where should I really start?
1.
Yeah, that's the mistake students always think of. And I understand you're just used to thinking in terms of whole numbers. There's actually a whole bunch of numbers closer to 0 than 1, like 0.1. And 0.001 and 0.0000001. There's numbers that are basically virtually 0. So really we do want to plug in 0, but it'll be our open dot. Am I making any sense? Was that just the Charlie Brown 111, 111? Let me try that one more time. Students often, over the years, I've taught this so many times, I know how you think, at least if you're like typical students I've taught for many years. They think, so Mr. Heron, I get it, you got to plug in x values bigger than 0, so the first thing is 1. No, you got to break with your whole number thinking. There's all kinds of numbers bigger than 0 before you get to 1. Numbers like 0.1 and 0.01. There's a lot of amount of monies between 0 and $1, for example, right? So don't just think whole numbers. The graph covers all values. So you need to think, you mean, so you got to do all the little numbers that you do? You got to find, if you just start at 1, then how do you have any idea what it's doing between 0 and 1? You have no idea.
Like a 0.5.
You get the idea? So really, you should plug into it. Yeah, but you can't. It's only right. I know. You're right. You can't technically plug in 0, but you can get infinitely close to 0. 0.0000001. Virtually 0. So just plug in 0, but make it an open dot. Do you guys know what an open dot is in a graph? That means you don't quite make it there. An open dot is a point you get infinitesimally close to, but don't quite touch. That's what we need. That's the open dots on the graph. So that's what you need to do. Even though it says greater than 0, we don't start at 1. We start at 0, and what I do is I just circle this whole thing, reminding myself when I put that point on the graph, it's an open dot, because I don't actually hit there. I just get close to there. All right, let's plug in. Plug in a 0. Y equals 1/4 times 0 plus 1. What's 1/4 times 0 plus 1? 1/4 times 0 is 0. Plus 1 is 1. Over 0, up 1. Open dot right there at over 0, up 1. That makes sense? So I took the equation, y equals 1/4 x plus 1, and I plugged in x is 0. And then I just worked it out. 1/4 times 0 is 0. Add 1 is 1. So that gave me the point over 0, but I made it an open dot because I don't really quite make it all the way there. I get infinitesimally close to it, but I don't quite make it there. Right? I only make it to values close to 0, greater than 0, they say. But not right on, not equal to 0. Not a solid dot, not a real dot there. but an open dot, a hollow dot. It's like it's been drilled out. That's what that open dot is. It's been drilled out. Then I need one more dot, so now plug in 1.
Would you close dot if it said greater than equal to?
Yes, if it said greater or equal, it would be a regular dot, because you would include it then. So y equals 1/4 times 1 plus 1. Does everybody see what I'm doing? I'm taking the equation for the right side, 1/4 x plus 1, and I'm plugging in 0, plugging in 1, so I want to get a couple of dots and connect the dots. So if you plug in 1, well, that's 1/4 plus 1, that's 1 1/4, huh?
1.25.
Or 1.25, yeah. So it's just multiple choice graphing, so we'll get it. Over 1, up 1.25. I'm going to kind of run out of room here. This one is over 0, up 1. Over 1, up. It's just a little higher, isn't it? Over 1, up 1 1/4. There it is. Connect the dots. There's the right piece of graph. Everybody see what happened there? So this point is over 0, up 1. This point is over 1, up a little higher than 1. 1 and 1/8. Just a little higher. Connect the dots. So there's our piecewise graph. It's a graph in 2 pieces. And so we go back for the multiple choice answers. Which one is it? Which answer looks right to you? See? Open dot in the middle, going up to the right. Questions I can answer on that? Not making sense? Let's try another one. I think that's so. There we go. So let me help you with this one. The first thing you need to do, I'm going to do a big graph here. Put this right in the middle here. Okay, is to find out where's the dividing line, like where's the separating line. We always have a line, a wall of separation, where you change from one graph to the other graph. Where, according to what they're saying up there, what x value creates the shift? -2. So that means what you need to do is come back here to -1, -2, and right at -2, put a dotted wall. Do you see that wall? You're going to have, on the left side of that wall, you're going to have one graph, and on the right side of that wall, you're going to have the other graph. How do I know? That's what it says. You do the 2x minus 1 graph when you're less than or equal to -2, when you're over here. And you do the minus x plus 2 graph when you're greater than -2. You're right of -2. See what it's saying up there? That's you starting to speak their language a little bit more? See what I'm saying? Let me help you with that. See what it says right here? You use this equation if x is less than or equal to -2. So on the x-axis, if you're walking around on the x-axis back and forth, when you're in x territory, less than or equal to -2, so when you're over here, you're going to graph over here the equation 2x minus 1 in this territory. Bless you. Does that make sense? See that's what it's saying right there? If x is less than or equal to -2, use this equation. And then you use the other equation, the minus x plus 2, if you're in territory on the x-axis greater than -2. So over here, we're going to use y equals minus x plus 2. Does that make sense? See what it's saying? See how I'm just following what it's saying up there? Which equation to use in which x zone? Which equation to use in which x zone? So now you basically have to do 2 graphs in one. One graph left of -2, one graph right of -2. And how do we do them? We just make a table for each one and plug in 2 dots, 2 numbers. So I'm going to go over here on the left. I'm going to say, okay, XY table. Now, whenever you make your XY table, you always want to include the wall of separation. So the wall is, because you need the negative 2. You need to find out what they're doing at the negative 2. So you've always got to include the negative 2. Right, when I make the table over here as well, I'm also going to include, maybe I'll move it up here where there's more room. You've also got to include the negative 2 in that table. Both tables are going to have a negative 2 in them. In both tables, you're going to include the wall. And then some other number in that zone. So, would it be a good idea to go negative 1 for that left table? Negative 2 and negative 1? Not at all. That would be, you start getting wrong answers. Why? Where's negative 1? Right here. Which zone is he in? Left side or right side? He's in the other guy's territory. Negative 3 would be a good idea. So everybody see, it's all about the territory. Negative 3, that's over here, yeah. Right? Because we're supposed to be working negative 2 and left, not right on negative 2. Huh. So for the other one, negative 2 and negative 1 would be a great idea. Because those are both in the right side, aren't they? Right of the dotted wall. Is that making sense? Questions I can answer? Is this making sense so far? So you just write both equations in both zones and pick x values to plug in that fit those zones. So then you just plug in negative 2 to the equation here. So I'm going to plug into y equals 2x minus 2. So 2 times negative 2 minus 1. What is that? Minus 4. Is it minus 5?
Yes.
I think that's minus 5. So that means that's the point, minus 2 minus 5. So minus 2 minus 1, 2, 3, 4, 5. That's right here. Minus 2 minus 5. Everybody good with that? I found that dot. Back to down 5. Should that be a solid dot or an open dot?
Solid.
How do we know it's solid?
It's equal. It's less than
Yeah, the
equal.
red graph
That's a bar.
has the bar. See right there? The red graph is for values less than or equal to negative 2. So it wants the border. Let's plug in negative 3 now. 2 times negative 3 minus 1. What's that, minus 7? So that's, what is that? Minus 3 minus 7. So here I should create more room. I didn't know where that was. 6, 7. So that's about right here, huh? Minus 3 minus 7, and this one was minus 2 minus 5. Connect the two dots, and don't go to the right of the line. I'll go left of the line. It goes left and down forever. Does that make sense how I graphed that left piece?
You're going to go through the x-axis for negative 2, right?
And so now graph the right piece. Graph the right piece. So for the right piece, right here, that's going to be circled, isn't it? Because it's only for values greater than negative 2, not equal to negative 2. So you're only supposed to do the right side for values greater. So it's going to be circled dot. Plug in negative, this is the equation what? Negative x plus 2. Plug in negative 2, be careful there. Watch your signs like a hawk. There's a negative in the formula, there's a negative in the plug-in. You're plugging into the formula negative x plus 2, huh? There's a negative right in the formula. That's going to be in addition to any x you plug in that's negative, right? That making sense? There. So I'm going to plug in y equals negative, and what's x? Negative 2 plus 2. So that'll be 2 plus 2, 4. Minus 2 up 4. 1, 2, 3, 4. Open dot right here at minus 2 up 4. Everybody see that piece of the puzzle? Right here. At minus 2 up 4. I just plugged in, I just took the other equation that I'm using for the right side, and I plugged in minus 2, because that's the border. We always plug in the border. And then I worked it out. And now let's plug in negative 1. How are we doing? Plug in negative 1. To this it's going to be negative 1 plus 2, right? Which is 1 plus 2, 3. Back 1 up 3. Right there. Back 1 up 3. Connect the dots.
And then 3 stays open, right? The circle.
No. Because we're supposed to do this equation for values greater than negative 2. So anything to the right of the negative 2 is a valid point. That's a good question. Is that making sense? Where any point greater than negative 2, right of negative 2 is valid. All those are solved. The only one that's open is this one, because you can't equal negative 2. So then you can grab the right multiple choice answer on that one. Man, that time went quick. I can't have any more visitors using up my first 10 minutes. Those are precious minutes. So how far did we get? Did we do